Have you ever stopped to think about the single most incredible material your body has ever made? I mean, it's something you use every single day. It's like a permanent suit of armor that was forged before you were even born, but it holds this fascinating, almost tragic secret. So let's dive in and uncover what makes this stuff so special and why its greatest strength is also its biggest, most fatal flaw. So, what are we talking about here? What is the absolute hardest substance in your body? You might think it's your skull or maybe your femur. Nope, the answer is your tooth enamel. But the real question isn't what, it's why. What makes it so incredibly tough, tougher even than bone? The whole secret is right here, in this one number, 96%. Your tooth enamel is 96% pure mineral. Honestly, it's less a part of your body and more like a piece of the Earth's crust. It's kind of like a living crystal, a biological ceramic, which is what makes it so dense and hard. But of course, that incredible strength comes with a pretty big catch. And this is the central paradox, isn't it? Your bones can mend, your skin can heal, but this super strong armor has a critical design flaw. It cannot regenerate. Once it's gone, it is gone forever. So how in the world is this one-time masterpiece even created? And why can't the construction crew ever come back to do repairs? To figure this out, we need to go to the source. We need to meet the microscopic construction crew that's responsible for this amazing feat of biological engineering. They really are the unsung heroes of your smile. So, say hello to the ameloblast. This is a super specialized cell with one single monumental job: to build your tooth enamel completely from scratch. It's born from this special layer of cells that kind of acts like a project foreman, and its entire life, well, it's dedicated to this one single construction job. So how does this master builder actually get the job done? The whole process is called amelogenesis, and you can think of it like a perfectly choreographed construction project that has several really distinct phases. Let's take a look at the blueprint. Okay, the entire project is broken down into these 5 main stages. First, the crew gets into position. Then they build the initial scaffolding. After that, they transition their tools, harden everything into the final structure, and then they perform one last protective duty before just vanishing. Now, the most intense part of the construction happens right here, in what's called the secretory stage. This is where the ameloblasts are working overtime, laying down the initial, soft blueprint for the enamel. You can think of it like building the organic scaffolding before you pour in all the concrete. And what is that scaffolding made of? Well, it's almost entirely protein. And one specific protein, called amelogenin, makes up a staggering 90% of this initial matrix. It's basically the master architect that's designing the entire structure. The ameloblast is just meticulous. It uses this specialized tip. It's almost like a tiny nozzle on a 3D printer to lay down this protein matrix layer by layer, and it creates this beautiful and incredibly strong keyhole pattern. But here's the crucial thing. At this stage, the enamel is still soft. It's only about 30% mineralized. Okay, now for the most critical transformation. That soft protein scaffolding is in place, but it needs to be turned into that rock-hard armor we were talking about. This is the maturation stage, or as I like to call it, the great hardening. This is so cool. The ameloblasts completely change their job description. They stop secreting protein and become a maturation crew. They actually flip back and forth between 2 forms. You've got the ruffle-ended state, which is pumping in massive amounts of calcium and phosphate minerals. Then they switch to the smooth-ended state, which is busy removing the old protein scaffolding and water. It's this perfect tag team. One adds the new, strong stuff, and the other cleans out the old, weak stuff. And the result of all that hard work, the enamel goes from being just 30% mineralized to its final, unbelievably dense state of 96% mineral. This is the exact moment it officially becomes the hardest substance in the entire human body. So, to put it simply, the great hardening is really the great swap. The soft, organic blueprint that was made of protein gets almost completely removed. And in its place, these ultra-hard, inorganic mineral crystals grow, creating the permanent, rock-solid structure we know as enamel. You know, this process is incredibly precise, but that also makes it vulnerable. So what happens if these microscopic builders get disturbed while they're doing their critical work? Well, it turns out the timing of the disturbance is everything. If the builders are interrupted during that early secretory stage, while they're still building the scaffolding, you get something called enamel hypoplasia. That means there just isn't enough enamel, period. But if the problem happens later during the maturation stage, the hardening, you get hypocalcification. The enamel's all there, but it's soft and weak and chalky because the hardening process just didn't work right. Which brings us right back to our central mystery. We've seen how this incredible masterpiece is built. Now, let's finally understand why it's a one-time performance and why that construction crew packs up their tools and leaves for good. After all the hardening is complete, the ameloblasts have one last job to do. They all fuse together and form this protective shield over the newly finished crown, guarding it while it waits to erupt through the gums. But once the tooth finally breaks through into the mouth, that protective layer gets worn away, and the builders themselves, they're gone. They vanish. And that's the final piece of the puzzle. The very specialized cells that knew how to build enamel are literally programmed to be lost as a final step of tooth eruption. Without them, your body has completely lost the blueprint and the factory. The construction site is permanently closed. So let's just do a super quick recap of this incredible story. The master builder cell is the ameloblast. It uses that key protein, amelogenin, to build the initial framework. It then hardens that structure to an amazing 96% mineral density. And the most important takeaway of all, can it regenerate? That's a definitive, irreversible no.
So your enamel, it's a biological marvel, a permanent, completely irreplaceable armor forged by a construction crew that worked tirelessly and then just vanished forever. It was built to last a lifetime, but it's the only part of you that can't be rebuilt. It's a true one-time masterpiece, so you gotta protect it.